Alright guys, thought I'd make you a practice test video this week, so see how it goes. Increasing, first of all, so determine the intervals in which this function is increasing, decreasing, or constant. Remember, look at it from left to right and use your x coordinates. This one looks like it's increasing. My graph isn't great there on the video, but looks like it's going from -5 up to 1. It's going up. Bracket around the -5, parentheses around the 1. It is constant. Which means it's horizontal between 1 and 3, so I'm going to go 1 and 3 there. And it's decreasing there at the end of the graph on the far left from 3 to 5. Doesn't go forever, it just stops at 5. Okay, number 2 says find the domain and range for that same picture. Domain is how far left and right the graph's going, and domain is x, use your x coordinates. It's going from -5 to, I don't know why I put a 1 right there. It's going from -5 to +5. Left to right. Range is up and down, and make sure you go down to up when you describe how far it goes, and use your y because range is y. It's down at -3 and goes up to +3. And I put brackets right on this because it does actually touch those points. Number 3 says graph that, meaning you can punch this in your calculator. Go to y equals, punch it. I kind of drew a rough sketch on my on my video here about what the graph should look like on your calculator when you find it, and it wants to know where it's increasing, decreasing, and if it has a max or a min. It's increasing from the vertex to the right, so it's going to be increasing from 5 to infinity. It's decreasing far left until it gets to 5. Remember, you're using your x coordinates when you're doing increasing, decreasing, because you're looking left to right. And the relative min is the vertex of your V shape, and really they want the what the x coordinate is at the min, so the min occurs at 5, and they want you to see that that's the transition where it increases, decreases, also happens at the maximum. All right, piecewise, first one says h of -4, so I'm going to come over here to the right side and look where the -4 would fit. -4 would fall in between 1 and -5, so I'm looking at the second equation, so it's just going to be 1. Second part says h of 6, same thing. 6 is greater than 1, so I'm using the last one. I'm going to plug it in that last equation. 6 plus 2 is 8. 3 would also fall in that last one because it's bigger than 1, so 3 plus 2 is 5. So I use that bottom one right there for the second 2 because that's where they fit. All right, I'm going to try to make this second part just a little bit bigger. Remember, when you start graphing piecewise, start with a point over here. They're giving you a 0, plug it in to that equation. -1/3 times 0 is 0, plus 2 is 2, so I'm going to go to 0, 2 on my graph, which is right there. I'm filling in the circle because there's an equal sign with that inequality. And the slope is -1/3, and also it says less than 0. Less than 0 means I got to go left, and the slope is -1/3, so instead of going down and right, I'm going to go up and left, -1/3. Go there, connect the dots, la la la. There's your first part. The second part, do the same thing. Plug in 0 in there. 0 minus 5 is -5, so I'm going down to -5, empty circle at -5. The slope of that one's 1. I'm going to rise 1, run 1. And I'm going to connect those, just like that. And there's your piecewise function. All you got to do is just graph your 2 or 3 lines, however many they give you. Given that f of x is x squared minus 2 and g of x is 3x plus 1, find each. First one says f minus g of 2. So the first thing you need to do here is find out what f minus g is, which is what I started working that out here. We'll finish here, so it gives me x squared minus 3x and minus 3. Now, what I need to do now, it says find f minus g of 2. So to do that, I'm actually going to plug the 2 in for all my x's. So it'll look like 2 squared minus 3 times 2 minus 3. Work that out. That'd be 4 minus 6 minus 3, which I think is -5. Looks pretty good. On number 7, f times g of 3. So the first thing you gotta do here is find out what f times g is. So do FOIL. First, 3x squared. Outer is x squared. Inner minus 6x. Last minus 2. Now, of course, plug the 3 in where you can. That was an x cubed, by the way, to start with. So I'm going 3 times 3 cubed plus 3 squared plus 6 times 3 minus 2. And again, that first one, that little blob right there is a 3. Sorry about that. So let me think here. That gives me 3 cubes. 27 times 3 is 81 plus 9 plus 18 minus 2. Actually, that's a minus 3 right there. Just saw that's a minus 6. Sorry about that. My handwriting here is killing me. as usual. So minus 18 minus 2. So 81 minus 9 is 90, minus 18 is 72, minus 2 is 70. And the last part over here says f divided by g of 3. Went ahead and set that up. F divided by g is all you can do. So I'm going to go ahead and plug the 3 in here. Now we get 3 squared minus 2. My numerator on the bottom, getting 3 times 3 plus 1. So on the top, I get 9 minus 2, which is 7. On the bottom, 3 times 3 is 9, plus 1 is 10. 7 tenths. And that's all you do on that one. So do the operations first, and then plug the number in that they give you. Okay, the next one's, you just got to find out all the new functions, and also tell what the domain is. Notice in my problem, whoa, don't know what just happened. Notice in my problem, there are no fractions or radicals, so my domain on this is going to be pretty easy. Remember, the only time you got to worry about domain is with radicals or fractions, so it should be good to go here. F plus g is just going to be 3x minus 1 plus 4x squared. F minus g would be 3x minus 1 minus 4x squared. Now, we'll say one thing about this. When you're doing these, if you can simplify some, you need to go ahead and simplify, but there's nothing I can add together. F times g is going to be 4x squared times 3x minus 1, which will give me 12x cubed minus 4x squared. So that's what I'm talking about. Sometimes you have to do a little bit of work. And f divided by g would be 3x minus 1 over 4x squared. Now, got to give domain. Domain of the first three parts, the f plus g, f minus g, and f times g would be negative infinity, all real numbers, negative infinity, positive infinity. That works for the first three. You might have to write that 3 times. That goes for the first 3. And the reason it doesn't work for the last one is because I now have a fraction, and I can't have 0 in my denominator. So I'm going to go negative infinity to 0, and also 0 to forever. So everything except 0 works in that f divided by g. Let's look at 10. 10 is a difference quotient. So the way I showed you to do this in class is from the top part first. Let's go f of x plus h. So I'm going to plug x plus h in for x and see what that gives me. If I work that out, that's going to be 6x plus 6h plus 2. F of x is just a 6x plus 2. So I'm going to come down here and I'm going to work this out, this difference quotient, meaning that's first, that's second. So I'm going to put 6x plus 6h plus 2 minus the 6x plus 2. And it's going to be all over h. So work out as much as you can. 6x plus 6h plus 2 minus 6x minus 2 all over h. And watch what happens. The 6x's cancel, the 2's cancel. So what that leaves me with is a 6h over h. Now the h's would cancel, so just get 6. And that shouldn't be a surprise based on, if you remember how we did that this week, that's not a surprising answer at all. All right, more fun stuff. F of g of negative 2. Remember how we do this. We work backwards. I'm going to plug negative 2 into function g first. And if I plug negative 2 into function g right here, it would give me 4 plus 4 minus 6, which is 2. So now I'm going to take that 2 and plug it into function f, which should be 3 times 2 plus 1. I just plugged it right there. 6 plus 1 is 7. That's your final answer right there, is 7. So work your way backwards. Number 12 says h of negative 3. So I'm going to plug the negative 3 in here. So I would get negative 3. First thing I would give is I would get negative 3 cubed, which is negative 27. So I'm going to plug negative 27 also into h. I'm going to get h of negative 27, which is really big. And I'm looking for my calculator. I wasn't expecting to have to use it. Let me punch it in real quick and see what I get. Sorry about this. I wasn't ready for that one. Negative, let's see, 27 cubed, golly, negative 19,683. That's crazy. All right, now, last one right here, g of f of 5. So I'm going to plug 5 into f, which is right here. 3 times 5 is 15, plus 1 is 16, so I'm about to plug 16 into g, which means I'm going to do 16 squared, which is 256, minus 2 times 16, which is 32, minus 6. 256 minus 224 minus 6, 218. 218 right there. All right, 14. Find f of g and the domain for this. So if I'm going to do f of g of x, that means remember you go backwards, I'm taking function g and plugging it into f. So it's going to look like this. It's going to look like the 5th root of x plus 2 to the 5th power minus 2. Now, the good thing about doing the 5th root and raising it to the 5th power is they cancel each other. So I just get x plus 2 minus 2, which is x. And that worked out really great, but you also got to tell domain. Now domain you have to tell as soon as you get to this step right here. What's the domain? And remember, you cannot have because it's an odd root, you are allowed to have negatives in there. The only kind of radicals you cannot have negatives in are even roots, like square roots, fourth roots, sixth roots. So my domain is all real numbers. That's how it was when I started, that's how it is at the end here. All right, 15 also says you got to find your f and g, so that's true. So I'm going to say f of x equals, remember there are more than one answer to this question. I'm not really showing you great ways to do it. It's just thinking through it and finding things that work. I think if I were doing this one, I would probably say f of x is x cubed and g of x is 2 minus 3x. Now think about it if you were to do this. If you were to do f of g, if I plug g into f, if I plug this function into that one, would it be that? And the answer is yes, it would. So that's good. All right, 16, just solve this inequality. So I'm going to first of all subtract 1 from all three sides, which will give me a negative 2x in the middle, 2 over here, and a negative 4 over here. Divide all three sides by negative 2. Now be careful when you do that. When you divide by negative, remember these signs flip. 2 divided by negative 2 is negative 1. 4 divided by negative 2 is 2. And there it is. If you want to go number line, you would go negative 1 to 2. Negative 1 have a solid circle. This would have an empty circle, shade in between. If you do a interval notation, you would go negative 1 to 2. 17, write a slope-intercept form through that point that is parallel to and perpendicular to. Okay, there's the slope, it's 2. So if I'm going to go parallel, I'm going to say y, I'm going to this point, passes through that point, y, because it works. Y minus 6 is 2 times x plus 1. Distribute the 2. Would give me 2x plus 2, and move the 6 over, you get 2x plus 8. That's the parallel. Then we do perpendicular, you have to do the opposite reciprocal slope. Use the same point. Now I'm using negative 1/2, but the same point. So I get y minus 6 equals negative 1/2, x minus 1/2. Move the 6 over, and if I move the 6 over, I would get positive 5.5, which is really 11/2. So there's that. 18, 2 more, we got it. 18, I drew the picture already. This is a building casts a 40-foot shadow when the angle of elevation is 70 degrees. How tall is the building? If you look at that one, it's a right triangle. That's why you can do it. And if I'm looking for the height of the building, it's opposite the 70. The shadow is adjacent to it, so it's opposite over adjacent. So I'm doing tangent 70 equals opposite over adjacent. And I'm going to be honest with you, I don't have my calculator with the trig functions with me. So the way you would do it is you would just do 40 times tangent 70 degrees on your calculator. And I'll let you punch that in because I don't have access to being able to do that. So there it is. One more. Given that 19. Sorry about that. Given that cosine x is negative 3/5 and is in quadrant 2, that's huge. Think about the quadrants. That means quadrant 2 is up here, which means your x is negative and your y is positive, which means your cosine is negative and your sine is positive. Find the other 5 trig functions. Well, secant, first of all, is just reciprocal of cosine, so don't have to do any thinking there. Now, there's 2 ways you can go about this. One is you can draw your right triangle and do SOHCAHTOA. I showed that. I did the 3. I do my theta right here. That's my theta. Adjacent over hypotenuse, which means that side. That's a 3, 4, 5. You can do Pythagorean theorem to find that out. Or you could do it this way, where you know cosine is x over r, which means your negative 3 is your x, your r is 5. And remember, r is the square root of x squared plus y squared, and you can work all the way through that, and you get y is plus or minus 4. And the reason it's plus or minus 4 depends on what quadrant you were in. Quadrant 2 means y is positive, so I'll put a positive 4 there, and I can just go now. Sine is y over r, which is 4 over 5, or you can look at your triangle, do opposite over hypotenuse. Just make sure your sine is good. Cosecants are reciprocal. Tangent is y over x. All right, my y is 4, my x is, look at that, negative 3, so it's negative 4/3, and my cotangent is just reciprocal of the tangent. Okay, and that's it. I hope that helps you. Please be ready tomorrow. I think you got a good chance to do real well tomorrow, so study hard, watch the video as much as you need to. See you. And of course, you can come see me tomorrow if you need to. So, see you. Bye.